So far, we've been dealing with balancing chemical equations, and they were quite simple, something like this. But I want to go into a little more complex chemical equation, and before I do that, I like to present a molecule that has polyatomic embedded. All of these have some type of polyatomic ions embedded within the entire molecule. For example, this one, H2SO4. Do you see the polyatomic embedded in there? Hopefully you were able to identify that SO4. This SO4, they're asking for how many of the SO4s are there. And there's only one of this entire molecule. Yes, there's one sulfur, there's 4 oxygen, but entirety of the sulfate, there's only one of them. So I can write there are only one sulfate, or one of the SO4 minus 2. Since sulfate ions are negatively charged. What about the next one? Well, I do see 1 here, so 1. But I also see the coefficient. And that coefficient, you need to take that into account in consideration. So you're going to have to multiply that by 2. Multiply that by 2. So now you have not just 1, but rather 2 sulfate, or 2 SO4 minus 2. Why didn't I multiply up here? That's because here in the front there is a coefficient of 1. However, 1 times 1 is 1, so I don't want to be redundant and write another number. So therefore it's just 1. How about over here? Do you see which polyatomic ion is present? Hopefully you are able to see the nitrate. The nitrate, there's one of them inside of the parentheses. So inside the parentheses, there's one nitrate, but you're going to take into consideration of the subscript outside of the parentheses, and that's showing that the 2 of the nitrates are there. We could even add the coefficient as well, which is just 1. So this one has 2 nitrates. Okay, you try for the next one and come back. And here's the key. You can see that 1 comes from 1 nitrate inside the parentheses. Then outside the parentheses is 2, so multiply 2, times it by the coefficient 4. To multiply all of these together, there are 8 nitrates. So for barium, just real quick, there are 2 hydroxide. Okay. So when you look at this balanced chemical reaction, you're going to look for the polyatomic ion. And so right now I see sulfate here and I see sulfate on my right hand side. I'm going to go ahead and put a circle around the sulfate. I'm going to keep it blue. Sulfate here, and then I have another sulfate on the right hand side over here. You're going to keep the polyatomic ion as a unit rather than trying to solve for this sulfur, and an oxygen, oxygen. Instead of going back and forth in that way, you're going to treat the entire polyatomic ion as a whole. And here's what I mean. First, how do we even begin with? Well, you're going to select the most complicated molecule that looks within this number 1. And to me, I think sodium sulfate, this looks most complicated. It's got a polyatomic ion, more numbers, more letters than any other ones. So I start off with here and I see that there's 2 sodium. On the right hand side, there's only 1 sodium. So our temptation might be to put in a subscript 2 next to the sodium, but let's not do that. We can only change the coefficient in the front. So we can add in 2 there. So in red, I'm going to go ahead and write 2. Now there's 2 sodium on the left hand side. Yes, it's subscript, but it doesn't matter. It's still 2 sodium and 2 here. What about chlorine? There's 2 chlorines here and 2 chlorines there. So that checks off the box, sodium and chlorine. How about sulfate and strontium? Strontium and sulfate, here is SO4. Here's another SO4. In the entirety, there's only one of them, right? There's only one sulfate on the right and one sulfate on the left. What about strontium? There's only one and one. So basically, I only needed to put the two. That's the only one that needed to change in order for this entire chemical equation to balance. Now for the next one. Looks even more complicating. It is, because now you're going to be dealing with not just one polyatomic ion, but two polyatomic ion. To keep it consistent, I will use blue as to identify the sulfate. So I'm going to go ahead and use blue right here and another blue one right here. What about nitrate? Well, nitrate is, I'm going to box it, and nitrate is over here in green, and then I have another nitrate over here in green. Okay. So if you were to just look at the polyatomic ion, it looks pretty balanced. One of the circles, one of the circles, one of the green on the left, one of the green on the right. But however, you can see how the difference in the silver and the hydrogen, right? So I'm going to, again, select the most complicated looking one first. And to me, it's either this one or this one. I'm going to start off with the product this time. Silver sulfate, there's two silver. What does that mean? I need to have two silver on the reactant side. So I'm going to look over here. Okay, there's no, there's only one silver. So I'm going to go ahead and put a 2 in the front of the coefficient to accommodate for the two silver. So now I have 2 silver and 2 of this entire square. 2 silver and 2 of this entire square, or the nitrate. So if I go on to the right, I only have 1 square since the coefficient is only 1. So therefore I need to put a 2 here to account for 2 of the square thing, which is the nitrate, right? And then, so now you see that 2 hydrogen, since you added a 2 there, and on the left-hand side, 2 hydrogen. So everything looks good. It's all balanced out.